Ahoy there! Welcome to a general software showcase video. Today, I want to look at creating a small Rust program that uses some of the crates that I've made in the past, and I'm also going to go over how I make videos. The first step to making a video is that we want to adjust the DPI of the monitor, because right now I'm on a 4K screen, and someone viewing it on the phone, the video will look pretty ugly if we don't change the scaling. In the terminal, I have a tool called monitor scaling, so I can do MS, and I can say I want to change the scale of my second monitor to 200%. So that will now have updated Windows. We go to display settings. That command has adjusted this drop down without us having to go to the screen. That is also a Rust program that I made. So to make a video, you need to record the screen. So I'm using OBS to do that. If you're sharing your browser when making a video, you'll want to turn off this thing that says show suggestions from history. So that way when you're typing, it doesn't show all your previous search history in the dropdown here. For demonstration, I want to show you how to set up OBS, and to do that without conflicting with the OBS that I'm actually using to record, we can run OBS in portable mode by going to the download page, downloading the zip, and then in the instructions, it says we have to create a portable mode.txt file. And if we just run the program right now without creating that file, it will reuse the profile and information from my existing config, which I don't want to do because I want to show the setup. If we create this portable mode, now when we run the program, it'll go through the first time setup. So I want to just optimize for recording. Let's aim for 60 FPS on my main display. So it's going to use hardware encoding, which is good. And everything else looks all right. And then we need to set up the scene. So in the scene, I want to record my display. So I'm just going to call this primary. So I want to capture my primary display and capture the cursor. And I also want to configure the audio recording. When we are recording, we have the desktop audio and the microphone, and we have multiple tracks that this can be recorded to. So what I like to do is everything will always get recorded to track 1, and then everything else will also get its own track. So that way, when I'm playing back the media, I don't have to switch between the different audios. So let's record a small test screen. So if I hit start recording on this instance, then this will record a file to some location. So it actually said recording saved to OneDrive videos, blah. If I go there, I actually want to change the default output location. So we can tell OBS to dump. We also want to configure some of these properties. So for recording, I have this in advanced output mode when configuring. So I want to have standard outputting to that location. And let's use hybrid MP4. And we want to use AV1. So this will be accelerated by the graphics card. I want 3 audio tracks. So one for everything, another for the desktop, and then one for the microphone. I will not rescale the output. For the bitrate information, the defaults are what I'm using in my other instance, which is good. So let's go with that. So now when I hit start recording, it will capture what is being played. And when we hit stop, we will now see that output here. When I play this with MPV, we see that it's playing back the information that it captured. And we have 3 audio tracks. One which has everything, another which is just the desktop, which in this case is the music, and then another capture what is being for me speaking. So this means that when we're in Davinci Resolve, we'll be able to interact with these tracks separately. And now that we have recording set up, we want to use Davinci Resolve to make sure that we can actually edit this file, because if you record a giant video and then you import it into Resolve, and then you realize that Resolve doesn't support the codec or whatever, you're going to have to re-encode the entire video, which is a pain in the ass. So let's open Resolve right now and make sure that we can actually open this file. And we should be able to drag this into the media pool. We'll change the project frame rate. And because we're making a 4K project, we have to go into project settings, change the timeline resolution to be Ultra HD. So now when we import this clip, it's actually showing it instead of media broken or whatever, which means that it's working, which is good. So when we're editing this later, we can turn off the track that's everything, and we can turn off the music and isolate just the voice instead of the music, which is what I'll do later, so that I can actually listen to music while recording without it being in the final video. So I'll turn my music back on. So now that we have the recording setup, that is how I'll be recording this next part, which is actually creating the application. And then later we'll go over the video editing, because in the video editing, there's a bunch of tips. So I think I've created a bunch of hotkeys for creating a slice, and then a hotkey for ripple deleting or normal deleting. Oh, yeah, it's right there. So here I have W set to razor, Q for trim start, trim end on E, 2 is ripple delete, and 1 is just delete selected. Basically, you want to accelerate the most common operations of this. So if you are editing and you're like trying to cut out the parts where you say, you want to be able to quickly get rid of those parts instead of having to switch tools and do more effort to get the same outcome. So we'll look at this later. For now, let's record a video about Rust. So I want to demonstrate some of my projects. So let's go to downloads, and we're going to create a new project. So what do we want this project to do? I want to demonstrate some of the tooling that I've made for Azure. And in Azure, there's the idea of role assignments. So in the Azure portal, there are resource groups, and those resource groups have access control associated with them. And you're granted access through roles and such. So if I look at the role assignments on this resource group, I don't see anything. So I can create a role assignment for a reader and say my admin account is able to read everything in this resource group. So to view these resource group role assignments, if you have a lot of resource groups, then it becomes tedious to go into each individual one to look at this access control blade. So if I have all of these and I want to see who has access to this resource group, then I have to go in here and I have to hit role assignments and then see it for each of these individual ones. So to have this as our baseline understanding, let's create a project that can interact with these tools on our own. Role assignment TUI. In this application, we are going to want to add some dependencies. So we need an async runtime, so we'll add Tokyo. We want error handling, so we're going to add color IR. And actually, it has just occurred to me that I already have a template for creating Rust programs. So what I'll do is I can copy that. So the reason that was so big, we open this in VS Code, is because I copied the target directory as well. So we can delete that. So when I'm getting started with a Rust command line tool, I want all this other stuff, and we can update the cargo toml to have this name afterwards. So let's do that right now. So in VS Code, when doing the recording, you also want things to be readable. So you can do zoom in, and the control plus stuff to zoom in that you're used to the browser, that only works when you have this area focused. So if you click here and then hit control plus and control minus, it will work. But if you're in the editor and you hit control plus, that toggles other stuff. So if you want the hotkey to work, you have to be up here. So I'm updating this Rust CLI template that I have, and we want to call it this thing. And then I want to overwrite all the files out here. So we'll replace all of that. And now we can delete that empty directory. And let's see what we have. So in our entry point to this program, we call main, and this actually needs to be renamed to our new project. We can transform it to snake case. I guess that doesn't work on this. This text power tools extension is very cool. So in our program, when we call main, that will bring us to this entry point where we're going to install color IR, which will give us colorful error outputs. And we're going to use IR results everywhere so that we don't have to care about error handling as much. And this template comes with some additional stuff that we will be able to strip out because we don't need it for this demonstration. So we can run our program and we'll get the help output from the default program, and we'll see all the commands that it comes with. So we have elevation, hello, and help. So in elevation, check, test, and help. So if we do check without the help, we'll see that we're not elevated. And sometimes you want to make a program that's going to do some privileged operations. If we do test, this will run the test program that demonstrates it's able to elevate itself, continue using the same terminal, and proceed normally. And this is useful for if you're doing some privileged operations. For example, I have a tool that I made that can read the master file table. And when I run the sync command, it will synchronize the disk onto a local file so that less privileged applications can read the master file table without themselves having to be privileged, because we're just saving it to a file so that something else can read it. And that operation requires elevation. And the plumbing to make sure that it stays in the same terminal is non-trivial. So I've included it in my template, and it's very easy to strip out when you don't need it, which we won't for this example. So to do that, let's get rid of all the Windows specific stuff, because that's what the elevation uses. We'll get rid of the elevation command. And then in here, this reuse console if requested came from Windows, so that can be deleted. Now if we run cargo check, we just finish removing all the build problems. So now I have hello and help, and what we want to do is create a program that can list resource groups and list role assignments for those resource groups. So to do that, I want to tell the AI, and while that's working, I'll go over some of the interesting things about this template. So part of the way that the elevation code worked is it has to rerun the program. And to do that, each of the commands is able to reconstitute itself to the command line arguments that invoked it. So when we call toArgs, this greet command is from the phrase greet. Although I suppose it doesn't make sense to explain this after I've removed all the elevation crap. So to do that, in the template for this elevation test command, so we have a check, which will check if it's elevated. And if it is, it'll print elevated. And if it's the test test command, it will say if it's elevated, then we print success. Otherwise, if it's not elevated, we will relaunch as admin. And actually, this seems a bit outdated because I think this has a more modern way to do that. So I'll have to look at that because in here, the sync command, when this is invoked, we call ensure elevated, and that is able to call relaunch as admin, and that takes the same invocation, same console, which I don't think this structure has been copied to here yet. Oh, it has. So what, we're just not using it for this test command? Oh, I see. So in here, when we're running the test command, instead of this being a idempotent operation where in the sync command, when we re-elevate or when we perform the elevation, we want to continue running the sync command in this scenario. So calling ensure elevated runs it with the exact same arguments. But in the test command, it's changing the command that's being ran from being the test command to instead being the check command. That's why we're reusing, why we're building the CLI structure instead of using the helper function that just reuses all the arguments exactly as is. So then we're able to run as admin this command, and instead of it being a list of strings that are the arguments, it's the actual command enum structure that is how we've defined our argument parsing to be done in the first place. And that's all because we have the toArgs function for each of these that lets us execute the commands. And the other thing is that we have arbitrary implementations for these commands so that we can generate random variants and ensure that the argument, the conversion to the arguments actually resolves correctly. So somewhere here is a test. So we can generate random data and create an arbitrary instance of the CLI seeded with that random data, convert it to arguments, and we parse the arguments from that list, and we assume or we assert that the parsed version is exactly the same as the original. So that way we know that the toArgs function is correct. So this arbitrary crate is very useful for generating random data or random instances of your structured data. Meanwhile, over here, I've told it to change the hello command into a list resource groups command. So instead of hello, we have list resource groups. The invocation of that command calls args.invoke. And then over inside hello, this has been removed. So list resource groups, no arguments right now. Invoke just prints stub. So now we can actually implement this command, and we'll do the run just for testing. So that worked. So now we want to add the code that's going to let us list the resource groups. So let's add cloud terrastodon Azure, and let's also add cloud terrastodon user and command as well. We don't need all of them right now, but just to save us time later. So if I want to list the resource groups, we just want to call fetch all resource groups. So this structure that I have is not asynchronous. So to run asynchronous commands, we need to build a runtime. So from Tokyo, we're not a Tokyo in here. Oh, that's right. I wiped the setup after copying the template. Let's add our lovely Tokyo back. So on a runtime builder, new current thread. Why is this? Zoom out a bit, perhaps. So now we have a runtime in which we can run our asynchronous code. So now we can print our resource groups. So this way, we're not assuming that it's going to be an asynchronous program at the top level by having Tokyo main up here. Inside the commands that need to be async, we can build a new runtime and run them as needed. So in here, we're going to print our resource groups. So now, when we run list resource groups, it'll now compile all those dependencies that we added, and it will print all the resource groups. So this is doing the Rust debug print representation. And because this is a command line program that we would probably want to pipe with other stuff, we can output it as JSON instead. We'll add serde and serde JSON and print that to stdout. So now we can say X is the JSON from that command. And now we have a PowerShell object that we can manipulate using other ways. So now we can integrate with other programs easily. And that's because even if we run this with our debug flag, which will give us more information. Version failed. So in our main, when we call main here, this should, I see the problem. We want to send this to stderr. So this needs to be updated in my template. So by sending the logging statements to stderr, when we do something like list resource groups in debug, when we get all the additional information, this we want to be in a separate text stream so that when we capture this JSON, we're not getting all this stuff here. And we can do that by sending this to stderr. So now if we say $x equals that, we still see the printing and the logging statements, but the value, the JSON is returned separately so we can interpret it, which is great. So now we have listing resource groups. And let's also print the role assignments for those resource groups. So if we call fetch all role assignments, now we have a list of role assignment, and this structure has the ID, the scope, the role definition, and the principal ID. So if we want to print the name of the role assignment, so if it's a contributor role, then it's going to point to the contributor role definition ID. So here, if you look at roles for contributor, the role assignment is just going to have this ID property, which doesn't tell us the name. We have to actually look up the role definition to find out what the role name is. So let's also get the role definitions. But instead of doing that, yesterday I created a helper. I thought I did. You know what? I did not publish the version of the crate. I just committed the code, but did not publish an update to the crate. So to fix that, I want to override this workspace, that dependency. So in our cargo toml, we're depending on Cloud Terrastodon. Now we have this function, which is not in a released version of the crate yet, but we're able to access it from our local copy of the repository. So this fetch all role assignments, role definitions and assignments will in parallel fetch the role definitions and assignments and create from them this structure that has some helper functions for joining together so that we can iterate the role assignments, and it will do the job of looking up what the definition is for each assignment without copying the information. Because this structure owns these other structures, when we're iterating, we're just going to get references to the ones within this owned one. So now inside of our project, instead of that, we now have this. And to fetch these in parallel, so the resource groups and the role definitions, we can use try join from Tokyo, get rid of the await calls, and now we want to print all the role assignments for the resource groups. So if we create a return object, which is going to be a vec, this is where we're going to dump our results. So for resource group in resource groups, for let role assignments, it's going to be our RBAC, and we're going to iterate the role assignments and filter to just the ones that match the scope. So this expects a scope implementation, and this ID we can convert into that structure. And then we're going to push the resource group and those role assignments into it. So inside here, we can add iter tools. So now when we're printing our JSON, we're going to print a list of objects where the first entry in the list is the resource group and the second entry is the role assignments for that resource group. And instead of that, we can do JSON. So we have the resource group and the role assignments. We'll give the role assignment and the role definition. So now when we run list resource groups, we can open this output in VS Code. So here is our output. We have the resource groups with the ID, location, managed by name, properties, and other information, and the role assignments that target that one. So this is my benthic cluster resource group, and we see this role assignment has an ID against that resource group, and the role definition is contributor, and we have all the permissions that that role definition gives. So if I wanted to see who is able to read this resource group, then now we have some information. So actions, the read action, if we look at what reader gives, */read, contributor matches that. And I did create a helper that's able to evaluate these, but I don't think I handled this case exactly. Let's try it. So this role assignment, for each of these role assignments, I want to say if it lets it read the resource group. So inside here, now we get our IntelliSense. So we want to create a role permission action from this value, and that will be what we are checking if this role definition satisfies. And we will include X there. So when we run this, it should tell us if that role definition is enough to give the read permission. So in this case, the contributor role grants star for the actions, which means can read true. And all of these are saying true because they're all contributor. So if we create another role assignment in this, let's create something that will not give that permission. So I just created a ACR pull role assignment for Teamy. And if we go here and run our program again, we're going to have a problem because ACR pull is not showing up. So inside here, this new output, we're not seeing the ACR pull because Cloud Terrastodon is caching this information. So instead of doing AZ group list every time we want to fetch all the role, every time the resource groups we want to fetch, it's caching this information. So in our app data, we have AZ graph resource groups. So when it's fetching, instead of doing AZ group list, that has an implicit subscription that's tied to it. So in Azure, each of the subscriptions is different. So when you do AZ group list, that's using the active subscription. And instead, if we want to fetch all of them, Cloud Terrastodon will use the resource graph. So the body of this request is a resource graph query that's fetching all the resource containers that are resource groups and getting the relevant properties from them, which means that this cached list for our role assignments is also being cached and does not include the one we just created. So we can surgically delete that cache entry, or we can just run ct clean and that will wipe the cache. So next time we run our program, it will refetch the missing information. And now we should see ACR pull is here with the permissions it grants is registries pull read. And here so let's just say microsoft.general/read. This is probably not what it actually is, but it should satisfy this example. So now inside here, when we look at the ACR pull role assignment, this does not give the read permission, but the other ones do grant read because these are all contributor and reader permissions. So we have contributor, reader, all of those are true, except for ACR pull, which is false. So using the crates that I created for Azure, we're able to quickly fetch all the role definitions and assignments and resource groups and do the prediction on whether or not that role assignment will give a specific permission that we're looking for. So the way this all works is when we call fetch all resource groups, this will return our list of resource groups. It's an asynchronous function. We have a resource graph query, which we're passing to a resource graph helper. And when we call collect all, this is calling fetch, and fetch is calling azrest method post with the URL to perform the resource graph query. And the results of the resource graph query, if we look at this in the standard out, it gives a column representation where the rows are not repeating the values each time. So we have to transform this information. So this resource graph helper is doing that for us. So when we run the request, so the resource graph query response has a deserialized implementation that will deserialize it first as a raw response, which gives the data, which is the columns and the rows. And to deserialize that, we are able to convert it using the try into implementation. So we can try and convert from the raw response, which is the column and row separation, into the actual one where the data is a vec of t instead of a vec of rows and columns. And to do that, we're calling transform. So transform takes our resource graph data with the columns and the rows and returns t. So for each row in this response, we're creating the map and then calling the traditional deserialize on it. And we have some debug implementation so that when a deserialization fails, we get some more information at the cost of cloning the responses when we're in debug mode. But otherwise, it rebuilds the map. So using the columns that were provided, it creates the key value that we can then use the normal deserialize from. That's how we fetch the resource groups. So instead of doing az group list, we're able to use the resource graph to get that information. And at the same time, this fetch call, we're building a Azure CLI command. So we don't actually have to have any authentication in the Cloud Terrastodon crate because all it does is call out to the Azure CLI and uses the Azure CLI REST to do the necessary operations. So this has the cost of going through the entire Python and requiring this CLI dependency, but it also means we get to not care about the authentication. It just becomes not our problem. So the same thing for the resource or the role definitions and assignments. This is just more resource graph queries, which we can copy and paste the query explorer. So these are the results that we're actually interpreting. So now that we have this code, we have a simple CLI that gives us some JSON output that we can then pipe with other commands. And it gives us the ability to rapidly create inspections on our tenant. So we could say there should not be any role assignments that meet some criteria, and then actually be able to assert that and then run that in a pipeline or whatever. So that's a simple CLI tool. And the things that we used the template for is it handled setting up the tracing and the logging. So all of this configuration that I usually do is part of that boilerplate, and setting up all the color IR, the command parsing, the elevation if necessary, and then invoking the command using the structure where each command and enum has this invoke function and calling it that way gets us all the way down here. I mean, it's something you can do from scratch, but I find the template to be helpful. Now, the next step is if we want to build something more sophisticated, then if I wanted to create a terminal interface for this, the Cloud Terrastodon crate has some demonstrations that we can reference. So for example, if we're creating a terminal user interface, then that is something that has a render loop where we don't want to be calling our large operations on the render hot path, like on the main thread. Usually you want to send that to a background thread. And this is a demonstration of how I can do that with the Ratatouille framework for building terminal interfaces. So if we're loading some thingies that take a long time, then there's a state for loading those. So when we call run, we have this work builder where we're able to dispatch a request. So the work is calling fetch all thingies, which is just an asynchronous method that takes some time. And when that response is received, we're updating the state of this app. So my app contains data, which is in this case a loadable list of thingies, where loadable is either not loading, loading, loaded, or failed. And that tracks the starting and finishing of each of those states. And it also has this thing for tracking the work. So when we when we run the app, we can enqueue that work into that work tracker. And then in our event loop, we're going to call handle messages from that work tracker. And then we will handle any keyboard inputs and then draw any stuff we care about in the terminal. So if I want to build a program that can list the resource groups in Ratatouille, it has a bunch of examples. So I can say, using the list example, we'll go back to our program. So we have this list resource groups, and we have this example from Ratatouille, and I have this example from Cloud Terrastodon for the app with the background worker. And I want to create a subcommand here for a resource groups TUI. So to do that, let's open a new chat and say, create a new command called resource group TUI. Stub implementation with an async runtime. So this request, we just showed it this file, and it will handle creating another one of these for the new command. And then from there, we will get the imports working for this worker stuff in the Ratatouille. So we'll have to add Ratatouille to this crate because it's not part of it right now. And then we can create a terminal interface for our app we just built. So that looks like it worked. So inside here, now we want to do the same thing as. So now we have that input or import. We can provide all of these files and say what kind of app we want. And there's a website called Asciiflow that we can use to kind of design this app to start with. So if we say this is going to be resource groups, and let's select and move that here. And then for each of the resource groups, we'll have a list and then the role assignments for it, or whatever item is selected. So in the list, one of these is going to be selected using, instead of a box, it'll be like a highlight or whatever. And then over here, we'll have a role assignments selected. So we're going to have a layout that's kind of vertical. So let's start with that. So we have all the information. Let's create a new chat. We'll add all open editors. So using add context, it now has access to all those files. And actually, instead of typing this out, I can turn on my voice to text, which is over here. So by hitting the pause button, it's now listening, and I should not have hit enter there. So let's stop that request and let's just create a new file over here for now. Test 1, 2. There we go. So I want a 2-column layout where the first column is going to have the list of resource groups, and it's going to be such that the selected item will, in the second column, display the role assignments that are associated with that selected resource group. It should have keyboard handling for the page up and page down and home and end buttons. So if we think about other terminal applications, K9S is a good one. I have no idea if this is going to work. It's been a while since I've logged in here. So this has, it's like navigation stuff where you can go inside and see what's inside your Kubernetes cluster. And we could build something similar where hitting enter on a role assignment would show other things that have that role assignment. So if we look at this code and format it, so when we call invoke, we have our app, which contains some app data and the list state for the rendering side of things, and it has our background worker tracker for this app data. So it's defining a bunch of stuff, and then eventually we're calling app default and starting the background work and then entering a loop. So instead of there being a run function implemented for this struct, we're just running it directly here. We have some functions for select, next, and stuff. So when we run, we start fetching the information, clear the terminal, we select the first item if present. So this will actually not do anything because the work will not have returned anything by the time we get here. So then we're handling the messages, we handle the keyboard inputs. So if it's escape or Q, we quit up and down, call page up, page down, and all that stuff. So this is overcomplicated. We can fix that. And then when we're drawing it, we create a horizontal layout 4060 for the resource groups. And depending on the state of their loadedness, it will display something different. And then for the right-hand side, we're displaying some other information. That looks gnarly, but we can iterate on that. So for select, next, and stuff, this RG list state, select RG, this all needs to be reworked. If we go here and say select, so the up and down keys should just call list state.select next and select previous. And then page up and page down should just call select next and select previous on the list state in a for loop for 10 times. And then home and end should just call the list state dot select last and dot select first. Now you can select any, select next, previous, first, last, next, previous. Instead of telling it to inline, I think the LSP will be able to do that for us. So wherever these are used, So now none of these are going to be used. And this is used only in one spot. So now we should be able to run this. So we get our resource groups, and it shows the role assignments for those principals. And in this case, these principals, when it's showing the role assignment, wherever it's doing that. So if the assignment is empty, we show some text. Otherwise, for each of the assignments, we map the role assignment to the principal ID. So this is not the display name of the principal. And to get that, we can say fetch all the users, because this principal ID could either be a user, a group, or a service principal. So if we fetch all those infos, we can determine which one it is. And to do that, let's say fetch all service principals, fetch all users, fetch all groups, security groups. So those down here, if we look at the principal ID, then this is going to be the unknown variant for all of them. So we can't match on this to determine which one it is. We'll just have to look at each of them and find out. So let's go back and build our next steps. So we go here, clear the chat. We'll reference that line of code and then here and say, in this program, when we are displaying the ID of the principal that is for the role assignment, we don't know if it's a user or a security group or a service principal. So what I would like to do is to use the loadable work stuff to fetch the service principals, users, and security groups. And then we can identify which one that ID belongs to by creating a lookup table for each of the principals. So once all that information is fetched, we can have a mapping from UUID to the display name of the principal. And the display name would also include, in parentheses, the type of principal it is before it. So in our app data, we can initialize this dictionary to be empty. And then once the loadable work calls the setter to set the result for the service principals or users or whatever to update the loaded state, when it sets it to loaded, it will also update that dictionary with the entries that it just retrieved. That way, in the render function, when we are determining the lines to display for the role assignment principal, we'll be able to look up this dictionary in O1 time to get the display value for that principal ID. So while this is chugging, might as well look at the details of this. So this loadable work builder is letting us do something in the background, and then when the work is finished, we're calling a setter with the result of that work in our event loop. So when we call handle messages, that work state has a channel that is created when the state is constructed with the messages for the finished work. And in this case, the message can only be a state change where there's a state mutator whose purpose is to take the state and update it. So it receives a mutable reference to it and it will perform the change. So when it calls handle message, the only variant it is a state change, and we call the mutate state on that state. And the message itself contains the details on what is going to be moved from the message into the state. So when we call a loadable work builder, this is something that has a setter and a function. So if we go here, so there's a setter, the function that takes the mutable state and updates it from the loaded state to something else, or from loading to something else. The work function, and so this is something that takes, or it is a future, and we track the location within the code where this function is called, so that when we get a error, instead of seeing the error message here where we are handling the messages or whatever, we're able to identify where the work was enqueued. So when we call .work, this has track caller on it, and it sets the location of that work to the location of the invocation of this function. And then the future gets tracked as the work that's going to be completed. So the work function is just a setter, and then build will check that the values are all present. So the setter function is something that takes the thing here. So self.setter, the type of that is a state for finished on work data. So that is a clonable function pointer that takes the mutable state and the new value of it, which is a loadable. So if it's not loaded, loading, loaded, or failed, when the setter is called, it's going to be one of these values. It's changing from not loaded or from one of these to one of these. And that is a operation that can fail. So if the work fails, the type of the error is also part of that loadable. So when we enqueue the work, we get the runtime. So in this case, it's just assuming that it's in an async runtime and getting the handle to the current one. And it will, on that runtime, spawn the future for the work. So this spawn function is handled by the runtime itself. So it will continue to be polled. And then in the event loop, we're calling handle messages. So in the background, we're not awaiting this future directly. We spawned it directly onto the runtime. So the return value of this is what? A join handle. So this join handle, we're going to track inside the work tracker for this work acceptor. So when we call the onWork thing, so when building this work, we provided it a future. So we're going to await that future. And the result of that is something that can fail. So if it's a successful result, then we're creating a state change work finished message from that result. So that result is a work success. And then if it's a failure, so if whatever was inside this future returned an error variant, then we have a work failed mutator that will be what is our state change. So the result of this work success is the work builder, when it's building the work itself doesn't have any notion of the state where it's going to, like if it's a loadable, that it's going to be updating the value from like not loaded to loading to loaded. It doesn't do that. It's just something that runs with a function that is called on the state when it's in queued, something that is the work itself, and then a failure handler and some description on if this should be discarded when the app is exiting gracefully. So for example, if you have a autosave functionality that is asynchronous, you would want to wait for that to finish when the app is trying to gracefully exit. But something like fetching information that you're just going to show on the screen, and if the app is exiting, you don't really have a screen to show anything to, then it's okay if that kind of work is discarded. So this loadable work builder, the function for when the work is in queued is we're calling our setter on the app state to set it to the loading variant at the time that this was started. And then the work function itself is we await the future and we have this success mutator. So this data is the result of that operation is we have a setter function. So we implement state mutator for this success mutator to say call the setter with the result of loaded on that state at the same using the correct started at value. And then the finished at is right now when we're setting the value to loaded, and the value itself is the data. And on failure, we create a failure mutator, which takes the error, and we implement the setter state mutator trait for this. So the setter function is called on the state to set it to the failed variant. So this on failure, we can see where this is called. So when we match the work itself, the work is just something that can fail. And if it's a success result, then we have this work finished message that we're sending on the channel. And if it's a failure result, then we're also sending a work finished message, but the state change that's going to happen is a failure mutator instead of the happy one. So it's all very over engineered and probably not the greatest, but I thought it was neat to create. So now the change that we just did here, let's see what was done. So instead of just calling these functions, we're properly dispatching the work for them. So fetching all the service principals, and for each of the values when it's loaded, the state principal display, which is a map from string to string, that could be a UUID to string. So let's change that. And actually this could be a principal ID to string. So now we have to update all the spots here. So this principal, all right, can we just do sp.id.clone.into? Like that. Do we even need the clone? Because I think UUIDs implement copy. Nice. So now here, this can just be, so the into implementation is from user ID, we can get a principal ID with the correct variant. And when accessing the value, the hash for principal ID is, it doesn't care about the variant. So even if we do a lookup for the unknown principal ID and the key is user ID in that dictionary, it should still resolve correctly because these are just new types over the UUID type. So here, the key is the principal ID, which in this case is always going to be unknown because when deserializing the role assignments, we don't know what kind of principal it is. It's just a UUID, but we can get it from this dictionary correctly. The other thing that this template does is I prefer the REST format with import granularity item and group imports 1. So that way, even if there's a blank space, when you format, it'll get rid of the space and it will put each import on a new line like Java, which I prefer. And all of these can also just be chucked up here. So now when our app starts is we dispatch a bunch of work to fetch the resource groups and the role definitions and assignments and the service principals and the users and the security groups. And once those are being retrieved, if it's the loaded state for each of those values, we're going to insert the display representation into our dictionary that's tracked inside the app. And that way, after we're done handling all our keyboard inputs and we're going to draw our information, when we're on the right-hand side and we're drawing the role assignments for the selected resource group, assuming that we do have something selected and we're able to identify which one it is, if it's not empty, then when we're displaying each of the role assignments, the principal for that we want to display is we're calling, so this principal display is a dictionary from the principal ID to the display representation, and we're formatting the role definition name to be followed by that principal display value. So now when we run our program, that seems to be odd. Don't know why it was, you know what, it's because even though we're in the Ratatouille full screen thing, the tracing subscriber is still set up to print the log messages, so that's causing some oddness, but for now. Now we see that when the role assignment targets a group, we get the group display name, or nothing, or a user, and then the user's name, or both, or a service principal. So here is our quick construction of a terminal interface for displaying stuff, and this can be expanded as you please. You could have it so that when you hit enter on a resource group or whatever, it will do some other kind of navigation. And this is a command that we could add parameters to, and we could create a different command or whatever, so that you can enter this however you want. So we could create a user TUI so that when you hit enter on a user, it would rerun the program, or it would suspend this app and would call the program again for the user. So actually, what would that look like? So the structure here is a little weird because this is a TUI for the list of resource groups. And if we start adding parameters to the command itself, it would make sense for the parameter to be the name of the resource group or something. So we could have the TUI for an individual resource group be something that displays the role assignments and all the resources within that resource group. And then when you hit enter on a role assignment or something, you could then go to the TUI specific for that individual item. So we would have a TUI for groups, and a TUI for users, and a TUI for service principals, or something like that. I don't know. But that is about the extent of the I wanted to go to for this demonstration. So in summary, we looked over how to set up things for recording. So in this case, using the monitor scaling to set things up so that even someone on a phone would be able to enjoy the content, and setting up OBS so that we're able to record the screen, which in this case, I'm recording with a different instance, which I'll have to pause to start doing the video editing. So we can close this one. And the configuration of the editor, it's like you don't always need to have the sidebar open. So you should be hiding that and focusing on the other stuff when you need to. And you can full screen VS Code to hide like the Windows stuff when you don't need it. And setting up a new Rust project, I have grown to always use the same kind of dependencies. So in this case, we're using clap for command line argument parsing, arbitrary for testing, color IR and IR for setting up error handling, and tracing and tracing subscriber for logging, wide string for Windows integration, so that could probably be removed along with Windows because we're not using any of the elevation stuff. Directories next. I don't know if I'm using that in this one. I guess that's not necessary. And then we're using Cloud Terrastodon for the Azure integration, Tokyo for an async runtime, serde for printing to the standard out with some Json, iter tools for collecting things into vectors easily, and Ratatouille for a terminal interface. And I have the Cloud Terrastodon repo cloned here so that I can edit it as we did to add the debug derive for that one thing. And what that gives us is in our main command, when we're parsing the command, we get all these extra helpful stuff. So now if we run help or with no arguments, we get the clap will provide us default help using the comments that we provided for our arguments. And we also have this global arg struct, which includes whether or not we want to print additional logging. So when this is true in our setup for the log level is for tracing, that will be used because we can say we want to use debug log level versus info or whatever. So this console thing could be removed because we're not using elevation. So now what is the name of this? Role assignment TUI. So we can install this onto our computer, and this will build it in release mode and add it to our path. So now we can do role assignment TUI. I don't know why that, oh no, it's because of these. That's why it's happening. So for that, this is just a error in the Cloud Terrastodon crate. So wherever it's doing fetching service principals or whatever, that needs to be made not an info level statement. So inside Cloud Terrastodon, these should be debug. Ta-da! So it's great to be able to patch Rust to tell it to use a local copy of a crate so that we can make modifications to it. So now, this video isn't just about creating this tool, it's also about the act of creating the video. So now I guess I have to edit the video, which would be moving that recording in here and then trimming it down. All right, I'm back. Took me a little while. I sat on the couch for a little bit, so this wasn't all hard work since I stopped. And I watched a bunch of YouTube videos on the couch for a little bit. But now we have this video that I originally recorded and was 1 hour and 40 minutes. And now we're down to 43 minutes. So I removed all the gaps and the ums and uhs, which was not entirely straightforward because some of the spots where there's no talking is you kind of need the narrative on what was being typed without any narration so that you can see the transition from one spot to another. And I'm sure I butchered a few of those, so that's going to be a little bit jarring. But that's the cost to pay, I guess, to get all the dead air out. And I wish I could automate that, or rather, I definitely can automate that, but at the point right now, I want to just get this video out there. So instead of building something to automate this for me or investigating how to export what I already did into some other tool, I just stuck through and finished the job. So now we have our timeline where there's markers for the YouTube description to add the timestamps to the videos, and we want to export that. So under the index, there's a way to do that, which I forget how to do. So under the edit index, we want to export the edit index, and we can show only the blue markers. So that's what I want to export. And then we go export edit index, and that will give us a timeline CSV file. So in our terminal, so I have a timelines chapters program that I wrote. So that'll take the CSV and set it to the clipboard. So if I look at what we just copied, this is the formatted representation, whereas the actual CSV file looks a little different. So inside the CSV, we have a bunch of different columns that we don't care about. We really just want it in the YouTube format, so that's what this program I wrote does. So now we have this file, which we can paste in YouTube. And with that done, the other part is I want to fix the audio. So when I did it earlier, in the Fairlight tab, you can select everything and do normalize audio. And that, the way it works is it will adjust the levels of the individual clips. So in this case, this one went from very quiet to loud, which I don't want because that's like typing sounds. So I hope it didn't do that for a lot of them. And I cut out most of that. But one of the things to know is that if you have one giant clip where there's a lot of talking and a lot of variance, then that will not be able to be normalized as well as if you had made all these cuts like I did to make all the ums and uhs go away. So I'll have to review this a little bit. And then that's the main thing, is exporting this timeline, doing something with the audio. You can also apply noise reduction to it. So in the Fairlight tab, we can do restoration, noise reduction, and this will ask for a part of the clip for training on what the noise is. I don't hear that much in this, so I'm not going to do that right now, but the tools are here if you want to change the way everything sounds. And you can also just export it to Audacity or something. But for now, I just want to be done with this. So I'm going to stop this segment and then export everything and upload it. So I lied, actually. I just watched everything over again, and I noticed that there was some background noise. So what I'm going to do is I am going to use the noise reduction, and in order to do that, we have to record some of the noise itself. So in the Fairlight tab, we can arm the track for recording here, and we have to patch in the microphone. So for audio track 2, I want to set the input. So we're going to map my microphone to audio 2. We're going to hit patch, and then we are able to hit arm for record and then the record button. So after just hitting record and then waiting, we have a segment of just the noise from the microphone, and if we elevate this, we'll be able to hear it. So that's what I want to remove. And to do that, we have our noise reduction tool here, so we can enable that and go to the settings, and we want to hit learn. And then we play the clip and it will learn the noise. So it seems to still be getting through a little bit, but that's probably because I cranked it all the way up. And there's probably a better way to do this, but for now, good enough. So now this noise reduction is applied to that whole audio track.